Pause. Before the video continues, there are two things to note first. The magazine is too heavy for the PewPew to carry. Secondly, the solenoid pusher in the PewPew is not powerful enough. Attempt 1. Attempt 2. Attempt 10. There's a lot to uncover from these demonstrations, so let's first start with breaking down the problem by looking at the magazines. Here we measure the spring force that fits the darts. On the left is the Mythical drum magazine, and on the right is an ordinary Walker Straight drum magazine. Next, we measure the resistance the pusher will face by pushing the darts out. These two experiments are repeated for multiple times until the highest peak force is found. It can be noted that the Mythical drum magazine has a greater spring force and thus pusher resistance. And while the pusher resistance can be changed with different internal springs, we also need to understand how such a change might affect the rest of the system. We can understand this with the help of a graph. Let the horizontal axis be the spring force that turns the star follower. Let the vertical axis be the drum's magazine's reliability and rate of fire. Pusher resistance and drum rotational smoothness would then be plotted diagonally, signifying an increased pusher resistance and rotational smoothness as the spring force is increased. Plot an arbitrary point for the 300 gram force peak for the drum magazine, followed by the 120 gram force peak for the straight hammer magazines. From this graph, you can clearly see that if the spring force is reduced, the pusher resistance should also decrease. However, reliability and drum rotational smoothness are also important, arguably more important than pusher resistance, especially to overcome potential rubbing of dart hits against the magazine wall. Unfortunately, decreasing the strength of the internal spring will not be an option because there are instances, although rare, where the drum can get stuck if too many dart hits rub against the wall. This was one of the major reasons why this particular spring was chosen. Therefore, for the PewPew blaster, it is unfortunate that the solenoid pusher is too weak and will not support the Mythical drum magazine. However, not all hope is lost. Take the commonly available solenoid with a 35mm stroke, one from Out of Darts. An identical size and stroke solenoid can be used as the starting point in determining the push force. The force of a solenoid push decreases with distance. However, the pusher need only to travel about 20mm in order for the dart head to reach the flywheels. Combining this with the fact that static friction to start the dart moving is generally greater than the dynamic friction when it is moving, we can therefore bet that this size of solenoid should be sufficient in starting the movement of the darts and successfully operate Mythical drum magazine. Here is another example solenoid of a similar size and stroke. In the force graph, you can see that it is also sufficient in overcoming the 300 gram peak force of the Mythical drum magazine. In conclusion, the PewPew blaster is unfortunately too small and underpowered for the Mythical drum magazine. Any other solenoid blaster with an adequately sized solenoid should have enough power to operate it. Mechanical pushers like in Strives should not have an issue, as demonstrated in my earlier XSW enabled Strive. Spring-powered blasters along with AEGs should also have no issue operating the drum magazine. More tests will be done on the various solenoid blasters to identify the suitability of them, along with field tests at the local games in Singapore before the launch of the magazines.